yeah, let's just jump into it and see how this goes.
Yeah, let's do it.
Cool. So first question that we have from Kishore, as far as I know, it's about Solana. Kishore says, as far as I know, every validator at Solana needs to be hashing all the time, a mechanism that forces all nodes to be hashing constantly to keep their clock up to date, almost resembles a proof of work system. Would you agree? And then the follow-up, am I correct in understanding the speed achieved by Solana is because the leader tallies votes and signs off on a block instead of having nodes reach a majority consensus themselves?
Yeah, so the first question has to do with the difference between VDFs and traditional work functions. When it comes to VDFs are sort of serialized functions. So when we do sort of like a normal proof of work consensus mechanism, like Poem, basically you do a hash, but every hash is independent of every other hash, right? So I have a header, I pick a nonce, I do a hash. If the hash meets the difficulty, I get a block or I get a share, whatever it may be, and I broadcast it. With a VDF, what you're doing is you're actually making a sequence. So you're saying the output of this hash is the input to the next hash. And then what I can do is I can say for a VDF, I'm going to require rounds. So I'm going to say, okay, you're going to do 100,000 rounds. So then what you have to do is you have to effectively prove that like you've done, the number of rounds, but basically the output of the first round is the input to the next round. And that's kind of what Solana is using to create like a tick on a clock. Because if you can say processors sort of operate at a certain speed, I can equate rounds to seconds. So that's sort of their concept of, I think they call it proof of time or proof of history. I think it's proof of time in Solana. But that's how they're using a VDF. Now, in terms of work, it's actually a very insignificant amount of work because we've actually been exploring VDFs relative to the merge bind transactions and elimination of MEV. And, we were kind of going through our heads and doing some trade-off calculations. So for example, if you said you wanted to do a VDF sort of as a mechanism to show that you've made a commitment a certain period of time back and use that as part of consensus, the amount of work that goes into that VDF is like very, 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 very small. So if we said we wanted, say we had a block and we had 100 transactions ordered in the block, and each one of those blocks required sort of 10 blocks worth of VDF time to submit and get ordering in that block, the amount of hash you would need to do that relative to the amount of hash that could be included in the block would be like 1/1,000,000,000%. Because effectively what you're saying is you are going to take that many threads out of the network for that number of blocks. So the amount of work you can represent in a sequential serialized function is incredibly small. So let's say we wanted to represent sort of all the amount of work, we would effectively need like 1,000,000,000,000 VDFs in every single block, which you obviously can't do from a commitment standpoint, a verification standpoint, or just a data standpoint. So you're just physically constrained at how much value and sort of energetic representation that can go into VDFs. They do represent something for time, but they're not economically meaningful quantities at all. And like they can never be economically meaningful quantities because you can't just stuff that many threads into commitments concisely. So they're two different things for two different functions. So I would not say in any way, even with proof of history, is Solana a work-based chain.
Got it. I think that makes a lot of sense. And then sticking on kind of the Solana trend, I fear, asked in Discord, can Quai handle network congestions? Since that seems very common now, even Solana has been recently experiencing problems with that.
Yeah, great question. The whole design of Quai is to handle network congestion. So when we talk about like what network congestion is, in traditional terms, we would talk about it as a DDoS attack or a Sybil attack. So what you need to be doing in all of the designs of these systems is you're creating a decentralized mechanism that is Sybil resistant. So when we look at centralized systems, the way that we do that is Cloudflare. The way that we do that is CAPTCHAs so that an attacker effectively can't just make an arbitrarily high number of requests to a website. The way that we do that in decentralized systems is through pricing. Now, the problem with pricing of transaction, that's helpful, but it doesn't mean you can't spam transactions into the mempool. So, for example, even Bitcoin and Ethereum in pretty much every blockchain in existence still suffers from this Sybil attack vector, which is I can broadcast a transaction, it can propagate in the network, and then I can do a new transaction that's replaced by fee. So effectively, I'm using the same nonce or I'm using the same account, depending on kind of what setting you're in. But you effectively create a new transaction that has a slightly higher fee than the old transaction. The network is then going to have to rebroadcast that transaction through the network. So for very little expense, sort of the cost of remaking a signature, you've created a cost to the network, which is broadcasting your transaction again, and they're only ever going to realize that fee one time. Now, Solana has actually two problems, which is their fee market isn't responsive and it's capped. So basically, because they have like a very, very low fee, there's sort of no imposition, not even using fund sort of replaced by fee mechanisms to propagate things through the mempool. There's a very cheap mechanism to create a DDoS attack, and that's effectively what OR has done, is they've created an incentive for people to create transactions, and people just spam the network with those transactions. And because their fees can't rise and they don't have a mempool, they can't deal with it. So like that's what's taking down Solana at the moment. But in terms of Quai, one of the things that's cool with mine transactions is if you get into a situation, so first off, we have a fee discovery mechanism. So as demand rises, if it precipitously rises intra-block, like fees will rise intra-block. Now, over time, the gas rate adjusts to sort of accommodate that. So fees will tend back down to their equilibrium price. But because the cost is not zero, it always is costly to do a sustained denial of service attack on the network. So if every cost is a penny and you can do, this 2000 TPS, it's going to take you effectively $200 or $20 per second for every second that you kind of want to like eat up the network's bandwidth. So you can do it. Now, the problem is costs are also going to rise on you. So maybe that becomes $40 a second, $100 a second. So the fees vary, but then with time, either through expanding the gas in a block or expanding the number of chains in the ontology, you can deal with higher throughput. So then the fees will readjust back down to ideally that equilibrium pricing of like a penny a transaction. So that's how we deal with it from a fee perspective. But from a DDoS perspective with mine transactions, you could actually use the mine transaction portion of it to even mitigate the RBF type DDoS attack on the network. What it really is saying is that if you want a distributed mechanism that's non-permissioned of DDoS resistance, the only known way to do that is hash. And so obviously that's one of the reasons we're a proof of work blockchain. That's one of the reasons we have mine transactions. And we can certainly leverage that to create the most robust, most Sybil resistant system possible that will offer the lowest fees possible for the given demand.
All right, I've got another question from Zach in the Discord as well. He says, this is more on the tokenomics side of things. So he says, so the chi price will be, quote, pegged to hash rate costs. So mining chi profit theoretically would be delta neutral because it's equal to hash rate cost. He knows mining rewards depend on chain difficulty, but still, how will mining chi profitable? Can you elaborate?
Sorry, let me just find that again. That was a long one. Hold on.
If you scroll up in the Discord chat a little bit, you should be able to see it.
What was his name?
Zach, and then in parentheses, Crypto Orzel.
Okay, I got you. So the chi price. On chain difficulty. Oh man, it just moved on me. Sorry. Mining rewards depends on chain difficulty, but still, how will it be profitable? Okay, so it's just a question of profitability of chi. So if chi has a useful function in the market, people will demand it independent of supply. They'll demand it because there's some there's a higher degree of fungibility in the Qi network than there is in the Quai ledger. And there's a endogenously stable expectation in price. So it's good to have sort of for a unit of account. And if it's the unit of account, then it would likely be the medium of exchange. So the thesis here is there's demand in the world for an e-cash-like system. So something that has the property of cash but settles digitally on a ledger for low consistent fees. So presuming that the market has demand for it, what will end up happening is the market will basically create a price, and that price will be reflective of whatever the relative current supply is relative to the demand. So if the demand is in equilibrium with the supply, our friend here, Papzak, is correct in saying that the price of production will match the market price. Now, let's say more people enter the network and they're like, man, Qi's great. Suddenly 7-Eleven starts allowing people to pay in Qi. They start pricing goods and services in Qi. Suddenly demand may rise, right? So now you have a disequilibrium state where the price of Qi is now higher than the market price. So then what they'll do is they'll say, hey, I can now mine this profitably because the demand is greater than the supply, so I can immediately mint it and then sell it at market and make whatever the delta is. So that becomes this sort of arbitrage opportunity between the production price and the market price. And then what ends up happening is that arbitrage opportunity shrinks to zero as the supply again matches demand. So it re-equilibrates. So there's this profitability window when there are changes of demand in supply. Or sorry, when there's changes in demand such that it affects what the equilibrium supply is. And that's how that works for miners. So miners also may just choose to hold it, not to sell at market, but just because they want to go risk neutral on their mining operations. Right. When you look at a lot of mining operations, they're actually set up as fixed income businesses. So they think of their business as just, I put in capital and I get a 10% return. They actually don't like exposure to Bitcoin or underlying volatile assets. They just want 10% return on their capital. So they go through the process of creating contracts in secondary markets or running options plays to remove their risk to the underlying asset. So they're just running profitability on Qi. Now, I will also say that depending on sort of where the equilibrium price is, there's always going to be some people in the market that may be a little bit more profitable than others with Qi. But what will end up happening is in equilibrium, whoever that is or isn't, like will or will not produce Qi until we get back to that equilibrium state.
Makes sense. Got a question in the Discord from Sargun, who asks, what makes Quai's sharding system superior to others?
So I do not know of any other sharded system that's work-based. So and honestly, proof-of-stake blockchains are blockchains in name only. They don't have real economic finality. They're not actually decentralized. And it's actually funny, they're realizing that they can't really come to consensus or make things immutable. So there's actually no blockchain that I know of that actually has sharding. I'll just put it that way. So we have sharding, no one else does.
Okay, for a similar question from Sargun, back to the tokenomics stuff you were talking about, which fee will users pay transactions in? Will it be Quai or Qi, or a combination of both?
So if they do a transaction in Quai, they'll pay in Quai. If they do a transaction in Qi, they'll pay in Qi.
All right, simple enough. From the Discord as well, HungPH asks, I've trained a chatbot with data from the Quai docs. Can you suggest which type of dApp that I can integrate on Quai?
I guess I'm missing the link between a chatbot on the docs and a dApp.
Well, there you go. I think that needs to be figured out.
Do you have an idea what his question is?
No, I think that if I had a chatbot like that, I would probably go to like projects that are already on Quai, so like Quaimark or something like that, and go to them and maybe try and make like a community or like a customer support flow for them using it. But yeah, I can't think of anything direct. I mean, there's a bunch of like AI projects too, where it's just like you have to pay an XYZ token like for credits or whatever to use the AI. But yeah, I can't think of anything super direct, but I'm sure there's a way to make it work.
Yeah, feel free to expand on the question for us.
Yeah, please. Um, Ted Star in the Discord asks, for those of us with less of a technical background, can you put into simple terms what makes/allows Quai to be infinitely scalable?
So it's two things. So okay. So what Quai Network is a hierarchy of merge mined chains. That structure allows us to shard state without sharding work in a work-based system. It also creates a natural incentive for topologically optimized self-organizing subnets. And all of that is orchestrated through a novel consensus mechanism called POEM, which allows us to deterministically weight every block that's produced in the system to create a representation that is guaranteed to be unique and represents the aggregate number of hashes in expectation that it would take to recreate a chain of that weight. So like those three things together kind of are what does all the work here. So what ends up happening is, right, we start out sort of in a single shard, and the network can measure its aggregate performance through uncle rate. So block sizes can increase and decrease with demand, but if block sizes keep increasing, the expectation is the uncle rate in the system will keep going up. This has to do with having fixed propagation delays over a fixed set of peers, but having the size of the data and the processing times of that data rise. So your uncle rate starts increasing. So then what happens is the system can measure that uncle rate, and it can say, well, I've had sustained demand at a high uncle rate, which is degrading network performance for some period of time. So we have sufficient economic demand to now have two shards. So then the system calculates an ontological expansion and adds a second shard. When that second shard gets added, we have a new state tree. We have a new throughput in terms of subnets. So now we have two subnets. Now each one of those subnets is going to end up with half the number of nodes. And they're going to be incentivized to topologically self-organize. So maybe we've split the globe into two. So we have kind of the Americas and Eurasia, right? And so because we've done that, we've dropped the number of hops needed in the system, and we've dropped the ping time between the nodes for that given number of hops. So we've actually improved the propagation delays. So we've more than halved them at this point. And we've made it so that we're only broadcasting transactions that need globally, which need that global scope, but most transactions don't. So we've made it so that we effectively need half the data propagating, and we've doubled the speed at which that data can propagate, and then we're storing that on a new ledger. So then as a miner or a node validator, you could choose to run a full node, which would double your requirements. But if you choose to just run a slice node, you can run one of these two shards, which means that no matter how many shards we keep adding, your node running requirements remain constant. So we've doubled the throughput of the network. We've more than doubled the throughput of the network because we've actually decreased the propagation delays. We've, basically have these two bandwidths now that we're pushing data through. We have two different data storage packages that we're pushing this data through. And then the only time that we sort of have to intercooperate is when we come up with inter-shard transactions, which you can do composably, atomically. But
I'm going to pull you back in, Dr. K.
Yeah.
So in simple terms, how would you, so at a simplest level, Quai can just coordinate many different blockchains into one network. Is that accurate?
I wouldn't even say it's many blockchains. Actually, I would say this is a single blockchain that has a sharded state root and privileged execution. So this is actually what threading looks like in a blockchain. So we really are a single blockchain with many threads.
Got it. Makes sense. Let's see. We have a question here in the Discord as well from NRK8. What unique ability does Poem have to coordinate those infinite number of execution shards, and how does Poem different from other like consensus mechanisms? Or I guess it would be better compared against like Nakamoto consensus or other like fork choice rules.
Yeah, so Poem was like a strike of lightning. We only came up with Poem a little over a year ago. So technically we were 4 years into this sort of idea of a hierarchy of merge mined blockchains before we came up with Poem. But without Poem, none of this is possible. And what Poem does is it creates a deterministic and guaranteed unique measurement that is compatible with the incentive of mining. So if there is a block in the network, everyone will always weigh that block exactly the same. And the weight of that block is as statistically accurate as the total energy that's gone into generating that block. So then what that means is that even though we have sort of many tips in the system, the tips are actually the leaders. So every one of the zones is like leading the system simultaneously. But because every block is guaranteed to be unique, we can always make the right choice. If we had something like Nakamoto consensus where we don't have determinism in tip choice, we wouldn't be able to do this. And even if you put like secondary constraints on it, and one of the earlier proposals of consensus, we had the hierarchical longest chain rule, but you end up getting into this sort of self-referential loop of like trying to figure out where consensus is, because if I go up, like I get an answer, and if I go down, I get an answer, and like the answer that, you know, goes up is different than the answer that comes down, depending on delays and latencies and orders of execution in the system. And so what's really like magical about this is if you say what Poem is doing, it's letting us agree without talking. So I'm broadcasting to you, but you don't need to talk back to me to get to agreement. And only with that property that no other consensus mechanism has can you execute this infinite scalability of having all of these shards. If there's two-way communication to get to consensus, like this is completely borked. You can't do it. And Poem basically guarantees that we'll always weight the block the same without having to talk about it. So I just give you the block. Your measurement of the block is exactly the same as the measurements I have of the block, and given the same information, we will always make the same choice. And that is like the magic of Poem.
Got it. So I have a bit of a less technical question here from Raven UA in the Discord chat. Yes, cryptocurrencies are being regulated heavily in the world lately. Will this regulation affect Quai in any way, either before or after mainnet?
So I can't say like what will or will not happen before mainnet. I don't see anything that's sort of in the pipe that I'm aware of that will actually come into effect before we go to mainnet. And after we go to mainnet, it's a decentralized system, so it's as regulatable as Bitcoin. It's less regulatable than Bitcoin because it's more decentralized. So I don't know what the implication of that is, but yeah, I mean it's an independent system at that point, right? Like it's just a protocol. People run the protocol based off the incentives. If somebody wants to try to regulate that in some way, shape, or form, I guess they can try to manage the global set of participants to do that. I don't know how you would do that, but I guess that's up to them.
All right. L Matrix asked in the Discord chat, referring back to when you were talking about how Quai can expand and add shards with demand. He asks, does the sharded structure also contract when demand is reduced or goes down?
Ideally, it would be. That's the one piece that we aren't really able to do cleanly. So we have not created that as part of the system. Now, aggregate demand still can, aggregate supply can still shrink based off the size of the blocks within the shards. but we do not have plans, and we do not currently have the ability to shrink the ontology.
Got it. We have a question from Alpha Mine DeFi, more on the mining side of things, but he talks about how the current algorithm is prog-pow based, lead to a bit of inherent ASIC resistance. But in general, his question is, how does the Quai team feel about versus ASICs, FPGAs, and ASIC resistance in general?
Yeah, good question. I actually want to answer something different first, and then I'll circle back on his question. One thing that has come into our view with our implementation of merge bind transactions is we are actually going to be able to implement shares for our all blocks, which means native to the protocol, you will be able to submit sub-block shares and get paid equivalently. So what that means is if you don't have a lot of hash rate, but you're willing to run a node, you don't need to use a pool. So it's sort of decentralized pool mining in the protocol. So that's... Go ahead, Max.
Yeah, no, I was going to ask a different level of question, but continue, please.
Yeah, so we think that's really cool. One of the reasons that we're doing that is one of the purposes for merge mining transactions is to create shares. Shares let us more accurately sample the network, which means we can lower our statistical uncertainty of the sort of longest tip earlier, which increases what's known as concentration. So to put that simply, if I have a system of miners globally distributed around the world, what I'm trying to do is I'm trying to understand, based off that hash rate, what is the current state of the system? So who knows sort of what in the system? And the way that Bitcoin proposes to do that is they, have 10,000 miners running, and it has a petahash of mining power, and they'll take one sample every 10 minutes. This has terrible concentration, meaning that sample could technically have come from, a USB miner. It doesn't represent 100% of the hash rate. It actually represents potentially like 0.00001% of the hash rate. So the certainty in that sample is very low. They only get certainty by taking samples over many blocks that they get enough concentration to get statistical finalization. What happens with mined transactions or even just naked mined shares is we are creating many samples in a single block. So not only are blocks 10 seconds, but they might have 100 samples. So what we're saying is not just the block sample, but 100 more samples are sort of in agreement with that block of what the last block was. So our uncertainty in the measurement of the system, which is how much hash rate is agreeing on the canonical state, is effectively zero in a single block. So we have, from a statistical standpoint, not an economic standpoint, really instantaneous finalization within a block, because there is effectively no uncertainty that that is the right measurement. And that's sort of the point of having mined shares. That's one of the points of having mined transactions. In terms of our opinions relative to GPU versus ASIC, we actually started out with ASIC-friendly algorithms. But one of the things that we actually want with the system, sort of with mined transactions, is we want impulsive hash rate. So one of the other things that we've understood about the system is when you're talking about finalization, if there is a orthogonal incentive to consensus, you want that orthogonal incentive to be fought over in a single block. If it's not resolved in a single block, that incentive remains for many blocks, which creates inter-block reordering incentives. So by having mined transactions, you actually sort of give the system a way to have impulsive, market-driven economic settlement bandwidth based off whatever orthogonal incentives may exist relative to consensus. So those things get adjudicated ideally in a single block. And that also helps from an inter-block reorg perspective. So that's obviously a huge advantage of GPUs because you can get that impulsiveness in the system, But then the other thing that we think about is the geostrategic nature of ASICs versus GPUs. Whereas if we actually achieve our goal and we become a global monetary system, there's probably going to be some jurisdictions that want to limit distribution and access. And if we're an ASIC-dependent system, they can readily do that by controlling import-exports on borders of application-specific hardware. But if you have general-purpose hardware, that's much more difficult to do. So that's one of the reasons we picked GPUs.
Yep, makes sense. I think that there's definitely a lot more to dig into on that as well, and we can answer those questions when we get to them. But I have a question from Felix Ooks in the Discord, who asks, he said, "Good day, Dr. K. According to the document and videos, you said that Quai is accepting smart contracts while Qi does not have smart contracts, while both are mineable. He's still confused on the purpose of Qi itself because it's not accepting smart contracts, dApps, or DeFi. If it's meant for spending, can you say that Qi is like a stable coin within Quai that can be spent for local goods? Or what is the purpose of Qi?" He's asking for more elaboration on the tokenomics and the purpose around that token. He says he's a bit confused about it.
Yeah, so the straightforward answer is what he said is indeed the purpose, which is you want an endogenous stable-like token in the system. It's not stable, relative to any other currencies, but ideally, when it's in equilibrium, it will be stable relative to energy, which will be stable sort of purchasing power globally. So then people can price goods in it. It becomes a unit of account. And then it also becomes a medium of exchange because it's naturally the unit of account. The reason that it doesn't have a smart contracting is because smart contracting destroys the fungibility properties. So if you want it to be cash-like, you need fixed denomination UTXOs without any distinguishment of having alternative sort of differentiation of those assets. So that's really the three things that it's trying to do. It's trying to be a unit of account. It's trying to be a unit of exchange through this endogenous-like stable property, and also provide fungibility. And none of those properties can really be had within the account-based ledger. The other thing that it's doing is it's really like a sort of a married system. One of the things that we've looked at, right, we're not just trying to create a crypto, we're really trying to create a monetary system. And if we want to create a monetary system, we have to create a sustainable monetary system. And so there's this thing called Gresham's Law, which basically states if you have a superior form of money and an inferior form of money, the superior form of money will be hoarded. We see this happen with Bitcoin. So if we compare Bitcoin to dollars, Bitcoin is the superior form of money, dollars are the inferior form of money. So Bitcoin gets hoarded and dollars get spent. But in long term, if you have a proof of work based system, you're going to need to have revenue generation. And our thesis is that we can generate revenue through transactions. But we can't get high volume transactions if nobody wants to spend their currency. So if you only have something that sort of everybody's wanting to hodl as a store of value, you won't get velocity in the system, you won't get transaction fees, and you won't have long-term sustainable security. So that's the other piece of the system, is that two-token mechanism native to the system creates something that's a store of value and something that's either stable or slightly inflationary, which creates monetary velocity. And that monetary velocity then helps generate fees to sort of perpetually secure the network, both for Qi and Quai.
Good explanation there. And I've got a question from Ariki Morrow in the Discord, who asks, why did you decide to fork the Ethereum miner for the Quai GPU miner?
It was just readily available. So there's certain things in these systems that are very important to us. Some things are not as important to us. So when we sort of make decisions of how to go about them, the less important things, we want to just take the simplest path, even though they're not the most optimized. Now, relative to the miner, those things can improve, those things can change. That protocol is Stratum compatible, so you can really have any miner you want. On the other side of it, and there's potentially market incentives to create those things. So from our perspective of, do we allocate resources to improve the protocol, to make it more Sybil resistant and more economically sustainable, create higher throughputs, all these properties, right? That's more important to us, at least now, than sort of optimizing the miners. So that's kind of why we made the decision. Now, anybody can do that in the community. If there's an opportunity to do it, they can technically make money off of it too. But in long term, if no one does it, we'll eventually circle around to those and make sort of better tools on those sides.
Nice. And then Mohsin asked a question that's also related to mining, saying, can you provide insights into the distribution of hash rate among mining pools on Quai Network, and how will Quai ensure a healthy and decentralized distribution of mining power?
So, I mean, we have some sort of insights. If you look at the Iron Age testnet, I think there's 30,000 or so, and maybe Max, you have the better number of unique mining addresses in the system. We don't necessarily know if that's all different people, but naturally speaking, that would likely be a somewhat decent representation of the number of disparate economic interests in the system. And I think there's an analysis out there that actually does the distribution relative to those 30,000 addresses. So, the data is there. People can look at it. I'm not intimately familiar with it, but it exists. I will say within Quai, because we end up in this eventually sharded hierarchy, as the system gets bigger, there is a dispersive nature to mining that does not exist in any of the other systems. Specifically, if I'm a miner, I want to operate at the centroid of my shard in the network topology so that I minimize my uncle rate when I produce a block. So there's this sort of dual incentive as the number of shards go up, which is I would like to minimize my latency as well as produce very cheap hashes. And the hybridization of those two factors are going to determine how to optimally mine. What that means is that if there's 9 shards, there's technically 9 geographic locations which are optimal for mining, which will make the likelihood of that all being under one entity lower.
All right. Got a question from Veronica in the Discord who asks, can you explain the difference between finality and settlement?
So I think for at least how I use those, I'd probably use those interchangeably. There's a difference between statistical finality and economic finality. Statistical finality is basically saying, based off what we know about the network or like what we have sampled, are you going to end up in a fork? That's sort of statistical finality. The economic finality is for the given transaction size, do I have an incentive that's larger than the economic work that's been put on top of that transaction to reverse it? And only when sort of the attack becomes more expensive than the exploit of reversing that transaction do you get economic finality. That is a property of work-based systems. Now, typically when we see that, say in Bitcoin, if you put Bitcoin on an exchange, they'll maybe like make you wait 6 Bitcoin blocks before they start letting you sort of trade assets. That is to both get statistical and economic finality. But that's really dependent upon the size of your transaction and how exploitable your transaction is. So if you're sort of buying a coffee, you'll get statistical and economic finality in a single block. Depending on what the block reward is, if say it's $5,000, if you do a $100,000 transaction, you'll technically have to write 20 blocks to get economic finality if you don't have sort of a correlated risk coefficient amongst other market participants or transactions at that point in time. This exists with all work-based blockchains. It's just we can talk about this much more specifically because we understand the problem, and we actually think we'll make a tool that for a given transaction size and a given sort of economic correlation coefficient anyone could predict what their degree of settlement is for a given certainty threshold. So you could have a sort of a dynamic system. So instead of saying, oh, it's just 6 Bitcoin blocks, it would say, well, 6 Bitcoin blocks gets you, and technically this is true, it only gets you about $1 million worth of finality. So if somebody deposited $2 million into the exchange should wait at least 12 blocks, not 6. That's just true statement of Bitcoin. And that's, again, presuming they don't have any sort of correlation to other transactions in the system, right? Because if I'm an attacker, even if I wanted to attack the system, I could potentially, make 5 transactions, all of $500,000, and then that's in aggregate $2.5 million. But if you're only sort of settling them to that $500,000 threshold, you're still vulnerable to an attack as an exchange. So, the real answer to any of these systems is this exists. We can measure it, and people should act accordingly.
Got it. Yeah, Veronica says all clear. Thank you. I have a question more on like the roadmap kind of planning side of things. So we finished 3 test nets now. We're planning for 2 more before mainnet. Can you explain kind of where we're at in the process of development? When do you think we'll be seeing the next testnet come around? What's the plan for launching mainnet, and when can people start expecting those milestones?
Yeah, so we're burning the midnight oil hard to get to an announcement for Golden Age. This is going to be largely sort of our feature complete testnet. So there's a lot of new features coming in. We've migrated to libp2p. We have like snap syncing. People won't have to set any funny settings on their routers to be able to peer into the network and run nodes. You basically have hole punching sort of in the system. And in terms of syncing, no matter sort of how deep we get, syncing should never be more than about 12 hours, given the snap syncing. So those are coming in. Chi is obviously coming into the system. Conversions between Quai and Chi are coming into the system. So there's like a whole new UTXO ledger and state tree. We have the mine transaction aspect, which does also provide MEV resistance if people want to use that feature. It also obviously enhances our consensus finality quite a bit through better concentration. There's also that introduction of the sort of that decentralized mining pool, which is basically just sort of a mine transaction without a transaction. It's just really a share. What else am I missing? We're bringing a lot into Golden Age, but those are some of the cool features coming into Golden Age. Dynamic ontological expansions. So previously we were testing 9 sharded systems in Iron Age. What we're going to do in Golden Age is we're going to start with a single shard, and then we're going to, once we're kind of happy with the single shard, we'll put transactions in the network until the uncle rate rises. The uncle rate will rise for a period of time. The controller will sense that and then dynamically expand out to 2 shards, and then we'll do that to go to 4 shards, 6 and 9 shards. So we'll test both the measurement and the dynamic ontological expansion. We're also testing the endogenous conversion mechanism between Chi and Quai in this testnet. The only things that are really remaining after this are we have like a state pruning sort of thing that we want to do between Golden Age and mainnet. There's some sort of in-node optimizations with how some encoding is done, but it's relatively a clean path after Golden Age. All the real features are going to be in this testnet, and then it's really just testing those features, creating better test coverage for the system, more integration testing, pen testing, auditing, and then we'll be on to mainnet. So mainnet is still planned for end of summer, and Golden Age should be announced any day now.
So you're saying the Golden Age is going to be feature complete, and that there's a couple things that are going to be implemented between the Golden Age and mainnet. Are you still planning on the Silicon Age testnet, or has that been dropped? Are we going straight from the Golden Age into mainnet?
No, so Silicon Age is still going to be helpful, but it's really just a dry run of mainnet. If we want to also use that as the mechanism by which we validate day zero integration partners, i.e. like market makers or exchanges, that would be a good use for Silicon Age, but it's effectively going to be a dry run of mainnet launch. So it won't be very long, maybe a couple weeks, and then it'll just roll right into mainnet.
Got it. And then another question that I saw some people ask earlier that I'll bring up, but what will like the claim process look like for people that have accumulated different, obviously there have been a bunch of different ways to accumulate Quai tokens that are be claimable upon mainnet. Do you have any insights into what that process will look like for people and when that will start?
Yeah, so we're putting together like a claims page. Depending on how you earned it, there'll either be sort of a social verification mechanism. So if you earned it relative to your Discord handle, you'll sort of have to OAuth into Discord, and then you'll provide an address for where you want that at mainnet. And then for the later ones where you have account, you'll basically end up connecting the wallet. You'll create a signature to that account saying you would like this to sort of be paid out to this address in mainnet. Is roughly kind of how that process is going to go. In terms of timeline, hopefully by the time we close up Golden Age, we'll have that ready to go.
Awesome. Excited. I'm looking forward to that for sure. L Matrix asked an interesting question here actually about the dynamic expansion. He says, so real demand is definitely one way to ensure that expansion is, only happening when necessary. Is there any way you can be sure that Quai will not suffer an attack that mimics demand that will consequently unnecessarily expand the structure and spin up new chains when there's not actually demand to justify it?
Yeah, I mean, you can't fully mitigate that, but we can price it, right? So if let's say we have one shard, and let's say that shard does worst case scenario. I think it'll be higher than this, but worst case, let's say one shard starts to get uncling at 200 TPS. And like I said, that's worst case. I think it'll be closer to 500 or 1,000, but let's just say it's 200 because we're trying to create an economic floor here for this exercise. Let's say there's no transaction throughput. Like you want to make a second shard here. So you're basically going to have to put all of those in yourself. It's going to cost you $20 a second to do. So that's going to end up costing you like $72,000 an hour, I believe. And like roughly, what is that? Call that $3 million a day, round figures here. And sort of our time to lock in, would be on the order of 10 days. So it's a $30 million sort of attack to get the second shard when the second shard shouldn't exist. But that's also presuming that the prices of those transactions don't go up as you're putting them through, which they will. So it's like probably at least a 3x multiple of that. So $100 million attack.
Got it. Makes sense. Let's see. The last question I'll ask here seems to be more technical from Raised. And this is also in the Discord. And I see that I share...
Sorry. One follow-up. That's also the worst case of one shard. As shards go up, that attack proportionally gets more expensive as well. So sort of the minimum case of creating a shard is a $100 million attack. But if you went from 2 to 4, that would be at least a $200 million attack. Right. So as the number of shards go up in the system, the cost of that attack gets more expensive proportionally.
Good addition there. Good clarification.
Yeah. And I'm also doing worst case. If we can do 1,000 transactions in a shard, like add another factor of 5 to that.
Makes sense. I'm going to get to Ray's question, and then we'll close this out. I see that I share the Caspa Discord with him, so expecting a good answer here, Dr. K. But he says, will any work functions be still not compatible with POEM, even with the theorized precision of current measurements?
Sorry, will any work functions not be compatible with POEM? I think I have his question. So the thing that you need to like make POEM work is your work function has to have both independent events and dependent events. So VDFs are not that. So you need independent queries plus dependent blocks. Like that's really like what Poem is realizing in the system, is that you have a series of dependent and independent events, and we're going to measure them appropriately. So as long as it does that, and as long as it has a field size which doesn't allow for collisions, it would be compatible with Poem. So I think your minimum field size for whatever hash algorithm you come up with would have to be at least 128 bits. I think there's probably a more optimal function in terms of statistical finalization at smaller field sizes. But as long as you have a field size greater than 128 bits, and as long as you have both dependent and independent events in the hash system, it would be compatible with Poem.
All right. On that note, we are coming up on the hour, so I do want to start closing it out. Appreciate everyone for joining in here. This was our first time doing a dual stream on Twitter and Discord simultaneously. So hopefully everything went somewhat smooth. I know it was a little bumpy in the beginning, so thanks everyone for bearing with us with that. But yeah, we really appreciate everyone coming to hang out with us and get your questions answered. Hopefully you learned a little something about Quai today. And are looking forward for the Golden Age testnet. Yeah, we had like 600, 700 people in the Discord audience today. Always insane to see, blows my mind. And then thanks to everyone here on Twitter as well. I see MH Ventures, shout out to y'all, and a bunch of other people, Ice Cold Abundant. I see a little Remilio in here now too. Love to see it. But yeah, thanks everyone for hanging out with us. We'll catch you next time. Tomorrow we'll be doing a Quai. Wait, not tomorrow. Today's Wednesday. Friday, we'll be doing a Quai Friday call with David, who's the COO here at Quai. So if you're looking for more like the institutional corporate side of things, have any questions around that, then that space will be for you. But Dr. K, as always, we appreciate your insights and explanations to things. Thanks for hanging out with us.
Yeah, thanks everybody for coming. Appreciate it. Let's get to Golden Age.
See everyone next time. Golden Age soon. Bye, everyone. Have a good day.
Sir.